Started? Okay. Good morning, everybody. My name is Ferhan Mazher, and today is 22nd of September 2020. Right now, I am with the 10 Matric class, and we are going to study about refraction. Today's topic is refraction of light. Okay? So, when the light is traveling, and we learned that the light travels in a straight line. When the light is traveling, light always travels in straight lines. So, for example, if the light is traveling in this air is a medium. For example, the light travels in a glass, the glass is a medium. For example, the light is traveling in the water, then the water is called a medium in which the light is traveling. You see, when light travels and it enters from one medium into another medium, the path of the light might change. The direction of the light might change. For example, if the light is going straight, it might bend a little bit towards this when it entered into another medium. For example, if the light is going this way, it might bend and it goes in this way. When the light enters from one medium to another medium, the direction of the light might change. This is called refraction. Another way of saying this is that when the light is traveling in one medium, it enters into another medium. For example, the light is traveling in air and it enters into glass. Or light is traveling in air and it enters into water. Or for example, when the light is traveling in water and it enters into air. So the medium is changing. When the medium changes, the direction of the travel of the light also changes. The light will change its path. It's going this way and then it goes this way. So you see the light changes its path. This is called refraction. Refraction of the light. If the light will change the path, because it entered from one medium into another medium, this is called refraction. This is called refraction of light. For example, let's suppose an example, and I will try to make exactly the same figure which is made in your book. Okay. For example, I have a glass slab. It's a rectangular glass slab. This is glass. It's glass. And this is air. Okay? This is also air. So I have a glass slab and I have placed it on a paper. I have a paper pasted on a drawing board, white paper, and I have placed a rectangular glass slab. It's a glass, it's a thick glass, rectangular shape, and I placed it on the paper and just mark its boundaries on the paper. Mark the outer boundaries of this glass block. For example, mark the outer boundaries. Okay? So this is the glass block. Now, take a laser. You know laser? Take a torch or a laser and put it here. Put the torch here or that laser here and direct the light of the laser here. Okay? The light which is coming here, when it will come across this face of the rectangular block, you will observe that the light will change its path. Okay? If I draw a normal here, this is a hypothetical thing, the normal. What you will observe, that when the light will enter into the glass, it will not follow the original path. It will be not following the original path. The direction of the light will change. It will change its path. You see what happened here? The light is no more going on the original path. It's not following the original path. It has changed its direction. This is called refraction. You see, when the light was traveling in air and it entered into glass, it changed its path. The light from air entered into glass, it changed its path. Okay, now see an interesting thing. Here, draw a normal, and you know normal is? Normal is a line which makes 90-degree angle with the surface of the boundary of the mediums. It is called normal. It's perpendicular to the boundary at the point where the light is entering into the second medium. Now if you consider this point here, the light is in the glass now, and it will come out into the air, and what you will see, or what you will observe, is that the light will again change its path. Whatever is its path in the glass, when it will enter into the air, its path will change. The light, when in one medium and it enters into another medium, its path changes. This is called refraction of light. This is called. So when the light will change its path, you see. So you see, one very interesting thing is happening here. Whenever the light enters from one medium into another medium, the path of the light changes. This is called refraction. This is called refraction. Another thing to be noted is, when the light entered from air into glass, you see, when the light entered from air into glass, the light bended towards normal. When the light entered from air into glass, it always bends towards normal. And when the light enters from glass into air, when it enters glass into air, it bends away from normal. Can you see that? Whenever the light enters from air into glass, it bends towards normal. And when the light enters from glass into air, it bends away from the normal. In simple words, if the light will, from a rare medium, it enters into a dense medium, the light will bend towards normal. But if the light will enter from a dense medium into a rare medium, it will bend away from normal. You understand? if the light will enter from air into glass, it will bend towards normal. When it will enter from glass into air, it will bend away from the normal. If the light enters from a rare medium into a dense medium, it bends towards normal. If the light enters from a dense medium into a rare medium, glass is dense, air is rare. So if it enters from a dense medium into rare medium, it bends away from the normal. You understand this? Yeah. So if you consider this example, here refraction is happening on two places. If you consider this whole scenario, the refraction is happening on two different places. So the refraction is happening here and the refraction is happening here. Here the light is entering from a rare medium into dense medium and the light changes path. So the refraction is happening here and refraction is also happening here. Because here the light is entering from glass into air. So in this whole thing, the refraction took place two times. One, the refraction took place here, and the second time, the refraction took place here. You know, when the light enters, if you just consider this portion, so this portion, this ray, which is in the first medium, I will call it the incident ray. This is called the normal. This is the incident ray. And the angle between the incident ray and the normal is called the angle of incidence. Here, this ray is called a refracted ray. This is called refracted ray. And this is that normal. So the angle between the refracted ray and the normal is called the angle of refraction. So this is the angle of incidence, this is the angle of refraction. You understand that? If you consider here, this is the second refraction which took place there. If you concentrate on this portion, then this will be your incident ray and this will be your refracted ray. So let me call it I1, R1. If you consider this situation, then this will be my angle of incidence. And let me say I2. And this will be my angle of refraction, R2. If you just consider this portion, then this will be your incident ray. And this is your normal. Then the angle between these two is the angle of incidence. This is your refracted ray. This is your normal. The angle between the refracted ray and the normal is called the angle of refraction. You understand this thing? Okay. So whenever the light will enter from one medium into another medium, the path of the light will change. And this is called the refraction of the light. And this is one good example of that thing. The light might enter from a rare medium into a dense medium, or from a dense medium into a rare medium. The path of the light will change. So, you know, if this is refraction, the refraction follows some rules. There are two laws. The refraction follows those laws. Very simple laws. The first statement of the laws of refraction is that the incident ray, normal and refracted ray, incident ray, normal and the refracted ray, they all lie in the same plane. They all lie in the same plane. Can you say that? Incident ray, normal and the refracted ray, they all lie in the same plane. What I just said.
Incident and they all lie like.
That's the first law of refraction. You should never forget this. This is a very famous question. He can ask you in the exam, they can ask you what are the laws of refraction. The first law is the incident ray, normal, refracted ray. They all lie in the same plane. So you should never forget this thing. Okay? The second and the very important law is that whenever the refraction happens, the ratio of sine I to the sine R, the ratio of the sine of angle of incidence to the sine of angle of refraction always remains constant. This remains constant. The value of I can be changed. Obviously the value of the R will change. For example, if this is the angle of incidence, this is the angle of refraction. Let's say this is 30 degree. Now you move this a little bit towards this. So this angle will become 35. Okay, move it further towards the left. This angle will become 40. You see, if you change the angle of incidence, obviously the angle of refraction will be different. But an interesting fact you will observe, whenever you will take sine I by sine R, the value will be always the same. The ratio of the sine of the angle of incidence and the sine of angle of refraction always remains constant. This is called, it has a very famous name. We call it Snell's. What we call it? Snell's law. What we call it? Snell's law. Sine I by sine R is constant. Okay. Another thing. This can be also sine R by sine I. This is the most universal famous thing. If somebody only asks you what is the Snell's law, you are supposed to go with this. But when you will be solving numericals, another form of the Snell's law is very important. Sine I by sine R is constant. Sine R by sine I is also constant. Okay. Sometimes, when I am working in the numericals, sometimes I use this formula and sometimes I use this formula. So the question is, in which situation I will use the first formula and in which situation I will use the second formula. It depends that what is happening with the light. It depends that the light is entering from which medium into which medium. I always use that formula in which, in the numerator, I always put that angle which is in the rare medium. For example, what I am saying, let me explain to you again. I always use, where's that? Yeah. So, let me show you one thing. Let me not this show you as an example. For example, suppose this is a swimming pool. Here I have a light. It's a swimming pool. It's a swimming pool. And the light came, and here is a light, electric light in the bottom of the swimming pool. And the light is switched on. So the light comes here, and here we have normal, and the light when comes it moves away from normal. You see, this is the angle of incidence. This is the angle of refraction. If I have this situation, so whether I use this formula, if I am doing a numerical, in the numerator, I always put that angle which is in the rare medium. Here I am talking about water and air. Water and air. So water is dense as compared to air. In the numerator, if I will apply this Snell's law on this situation, it should be sin R by sin I. That should remain constant. You understand? Snell's law, in the numerator, I always put that angle which is in the rare medium. Take one example. For example, you have a glass block, and inside the glass block I have a torch. This is the torch, the light, and sorry. So the light is coming. This is the torch. This is normal. Light. Okay. Air glass. This is air. This is glass. This is the angle of incidence. This is the angle of refraction. In this example, the light is entering from air into glass, from a rare medium into a dense medium. If you have to apply the Snell's law here, the shape of the formula will be sin I divided by sin R. That will remain constant. Do you understand this? So whenever I write the equation of the Snell's law, in the numerator, I say upstairs of that fraction, in the numerator, you always use that angle which is in the rare medium, because two mediums are involved. No? Whether it is angle of incidence in the rare medium or whether it is angle of refraction in the rare medium, upstairs always the angle which is in the rare medium. So the Snell's law can be sin I by sin R, remains constant, or you may say sin R by sin I remains constant. You understand this? Ready? Huh? Do you understand? Okay, good. So this is called by the Snell's law. Okay. Another thing, we move forward. So, do you understand this whole thing? So, I'm going to raise it. So, now, another thing, you see, in Snell's law, we studied that the sin I divided by sin R, that remains constant. For example, when the light is entering from from air into glass, so we wrote sin I by sin R, and that remains constant. And let me say this is n. the number n which you get when the light enters from the air into glass, and you calculate sin I by sin r, that will remain constant, and that constant is represented with n, and it is called refractive index. This is called the refractive index of that glass. Okay? So the n value is called refractive index of that glass. We have another formula for the refractive index of the glass. That is the n, this is called refractive index. So the formula for n can be sin I by sin r. It can also be sin r by sin I. There is another formula for the refractive index of light, and that formula is the speed of light in air divided by speed of light in medium. For example, if you want to calculate what is the refractive index of this glass, some particular glass, so you will somehow calculate that what is the speed of light in this glass. What you will do, the speed of light in air divided by the speed of light in that glass. So that will give you the refractive index of that thing, that glass. The speed of light in air or speed of light in vacuum, this number. That's a famous number, and it can also come in your MCQs. The speed of light in vacuum or speed of light in air is 3 expo 8 meter per second. Okay? So whenever a numerical comes which involves this formula, remember they will not provide you the speed of light in air. They suppose that you remember it. So kind of remember it. Okay? Keep it in your memory. So speed of light in air and the speed of light in that medium. This is the second formula for the refractive index. And this refractive index, this whole thing can be also represented with a C divided by V. Here C means speed of light and V means speed of light in that medium. Okay? So this is there is another formula which is not given here, but I can tell you that is real depth divided by, this is not, I think, in your book, apparent depth. So another formula for the refractive index is real depth divided by apparent depth. For example, let me show you that thing. For example, if we have, suppose this is a swimming pool, and here you have a light. So the rays of light which will be coming out of the swimming pool. For example, this ray goes this way and this ray goes this way. For example, when this light will go into the air, it will bend away from the normal. When this light will go into the air from water, it will bend away from the normal. If you prolong them, they will intersect each other here. So you see, when you are standing outside the swimming pool, for example, if you are standing here, you are outside the swimming pool. That light is at this depth. But when you will be standing outside, from outside this light will not appear on this depth. From here you will get a perception that the light is coming from here. The real depth is this much. This is the real depth. But when you see from here, you get the perception that depth is this. So this is the real depth and this is the apparent depth. The depth, whenever you are standing outside a swimming pool or any pond or any stream, the depth which you perceive while standing outside the water is always less. The real depth will be always more. This happens because when the light comes out of water, it bends away from the normal. That's why you might have heard that there are some people, what they do, they have arches, and with the help of the arches, what they do fishing. They have a spear and they go in the water and they slay the fish, and with the spear they